Okay, so going back at 2019, quite a few questions here. So question 5, the difference between a census and a sample. A census includes everyone in the population. Okay, and a sample is a small part, of the population, which should be representative of the whole population. Which should be representative of the whole population. Okay. Part B. A market researcher is interested to find out the opinions of nurses living in Northern Ireland. So he is asking those only at the one hospital on a Monday morning after 9. Okay, so only at one hospital. That'll be per. Okay, only on a Monday morning. Only on Monday morning. Only at a specific time. Oh, and it's only women. What's that there? Only asks women. Okay, so that's a few more than 2 there. Question 6a. Okay, calculate the mean and standard deviation. So the mean is when you add them up and divide by the number you have. So if you add them all up, you should get 2995, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 there, giving you a mean of 272.27. It's also looking for the standard deviation, so it's sigma x squared over n minus your mean squared, square rooted. So sigma x squared is 831,067 divided by 11 minus the mean squared. Let's plug that in. 272.27 squared. And then square root the answer, giving me a standard deviation of 37.7. Okay, outliers, liars are defined as this. So let's work out our outliers. It's part 1, part 2. So it's what to do with the quartiles. So I've got to work out the quartiles first. So I've got to put the numbers into order. 221. Oh, they already are in order. 248, 251, 255, 259, 263, 264, 272, 291, 297, 374. Lower quartile is at the n plus 1 over 4th value. So n is 11, 11 add 1 is 12, 12 divided by 4 is the 3rd value. So my lower quartile, 1, 2, 3, is 251. My upper quartile is n plus 1 over 4th value times 3. It's going to be the 9th value. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 291. Okay. So outliers. I have got 1.5 times the upper quartile minus the lower quartile. So 291 minus 251 times 1.5. So it's going to be 60. So the upper limit is 291 add 60 to give you 351, and the lower limit is 251 minus 60 to give you 191. And we have got 374. So 374 is outside this range. Hence, it is an outlier. Okay. Part 3. Further investigations suggest that the weekly income of 374 was recorded incorrectly and it should have been lower. What effect would this have on the standard deviation? Now, the x standard deviation up here, the x squared is going to be lower, the mean is going to be lower, so the standard deviation lower. Part 4. The interquartile range didn't matter about this one, so it stays the same. Okay. Part B. Histogram. Okay, let's have a look at this. Complete the table. Right, so first of all, I am going to rewrite the table. And I like to do that. So the first one, incomes, is 150 up to 180. The next one is 180 to 200, 200 to 250, 250 to 280, 280 to 350. Frequencies, 45, 52, 120, blank, and 35. I'm going to do frequency density because it's used as a histogram, so it's frequency over class width. So it's 45 divided by the class width of 30. So 45 divided by 30 is 1.5. That helps me label up the sides. 52 divided by 20 is your 2.6. 120 divided by 50, just want to check them all, is 2.4. And the last one, 35 divided by 70, 0.5. So 5 wee squares is 0.5. So to get this here bar, the 250 to 280, it's going up as far as oh, lost my point there. So here, so the 250 to the 250 to 280. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's up to 1.1, 2, 3, 4, 5, 6, 7, 8. So it's 1.8 times the 30. Remember, frequency is when you find the area of the bars. So it's 54. So 54 is your answer in there. Part 2. That was part 1. Part 2. Estimate the probability that they have more than 230. Okay, so I'm going to do is I'm going to have to split this bar of the 200 to 250. So here's my bar, 200 to 250, and I want above 230. So 230. This bar goes up to a height of 2.4. I want more than 230, so I want in here. So the area of that bit of the bar is 20 times 2.4 to give me 48. So more than 230. I got 48 from this bar. I've got 54 from the next bar, and I've got 35 from the last bar. So 48 add 54 add 35 gives me 137. There, where have I got the total frequencies altogether if you add up all of those? So 45 add 52 add 120 add 54 add 35 is 306. So the probability they're looking for is 137 out of 306. Okay, and also from this paper we are going to do question 7. That's a PMCC, which is number crunching. PMCC is the SXY over SXX SYY. So we'll go over to the side to work out all the stats. So SXY is the sum of the XY's minus n times the mean the x times the mean of the y's. Okay, I'm just going to plug these straight into the calculator here and just go for the first one, 2.5 times 3.2, add 1.8 times 3.6, add 1.7 times 4.6, and so on. And if you add them all like that, you get 67.13 minus, and I have got 10 years, and the mean of the x's, or the unemployment rate, total of the u's is 19.1 out of 10. The y's, or the w's in this case, the mean is the total divided by the number. So plugging all that into the calculator, so this is 7.13 minus the answer gives me an answer of minus 6808.87. Hope my figures are right here. SXX is the sum of the x squared minus n, the mean squared. The sum of the x squareds, if you work those out, that should be 37.53 if my work is right. 10 times the mean squared is 19.1 over 10 squared. So let's see what we can do with that. Just plugging it straight through the calculator here. I have got 1.039. SYY, doing the same for the y's, or the w's in this case. And hopefully these figures are correct. So it's 10 times 36 over 10 squared. Again, just plugging these in. So 4.26. I have got here 4.66, plugging those into the PMCC, minus 6808.87 over 1.039 times 4.66. Now, let me see. I must have gone wrong somewhere because I have got a negative value which I should not have. Just trying to work out where that is. So 67.13 minus 19.9 times 3.6. Let me double check this. That seems a very high number up there, doesn't it? So 19.1 times 36 divided by 10, 60. Just double. I think the error's here. Minus 10 times 1.91 times 3.6. It is indeed. So it's minus 1.63. So I knew that because I didn't have an answer between 1 and minus 1. Let's see if that makes any difference. That looks a bit better now. So minus 0.74. Comment on the value. That is negative correlation. And let's put it into context. So as the unemployment rate increases, so as unemployment rate increases, the change in wages decreases.